Welcome to EDU World Space.
Hi everybody. So we're looking at this figure right here, and I kind of uploaded a giant one. But let's bring it down. Not that down a little bit. But we're looking at this figure right here, and we want to show the ratio of any two successive maximum displacements of x naught. Oops, that's me. So x naught and looks like x n plus 1. Okay. And is a constant in the natural logarithm of this ratio called the logarithmic displacement. Okay, so here we're trying to prove what they gave us, and we're also trying to find the xn and xn plus 1. So from this, we have x naught here, and up here, if I can find it here, okay? So in here we have this equation, x equals e minus c 2m. That's supposed to be a 2. 2m t c1 sine w dt plus c2 cosine w d for the damping t. And you can always tell that I always make my t's like this so I don't get confused with my plus sign. That is one way to kind of help you when you do math, is try to make your letters as clear as possible, especially your plus sign. So now we have frequency, the damping frequency is this, and it's the number of times it goes. And we have 1 minus the damping factor squared. Okay? And these are the equations we're looking at. Okay? And for the vibration of the amp, here we have x equals x naught e minus c 2m t. And then we have sine times the damping factor, and we forgot the t, times t plus phi. And I'm just going to separate this from a little green line so you guys can see it better. And this is from, the sine is because this is a sine wave. And you can see that if you see right here, we're getting this number from that, okay? If you're just curious, okay? So here we have, we're gonna put in these factors that your t is gonna equal tn, that's the number of times. Your x is gonna equal the number of times, which is xn, the displacements, okay? So now we're just going to plug it into the above this one right here. So we have xn equals x naught e minus c 2m tn times sine w dt plus phi, okay? And we're going to have this equal to 1. And this is going to be a. And now we want to do the maximum displacement. So we want to do the max displacement. Because here we did the vibration of the diminishing amp. So vibe of diminishing amp. Okay, so for the max displacement, we're going to have t equals, and we can do this in green and keep it kind of the same. So t equals tn plus 1, and x is going to be equal to x and plus 1. Okay, and here you're looking at series, by the way, and this is series, okay? And that's something that you'll get used to at doing. Once you learn these patterns, and you'll have these series and your sine waves and cosines. Okay, guys? Okay, back to this. So xn plus 1 equals x naught e minus c divided by 2m times tn plus 1. And from that, we have sine wd tn plus 1 plus phi. This is going to equal 1, and this is going to be your b. Okay? I'm just going to scroll down. So from this, we're going to set our WD Tn plus 1 equal to our WD Tn. Okay, we're saying A and B. I guess A and B equal from the inside here. Okay, and minus the phi part. And from this, if we do this, we end up with, we get 2 pi. And we're going to bring this over to here, and we end up with 2n plus 1 minus 2 minus tn equals 2 pi wb. Okay? So now we're just going to have this divided by each other. N plus 1. And this is, make sure we get all this written out. And there we go. So we have x naught times e minus c 2m tn divided by x naught e minus c 2m tn plus 1. And if we do this, we end up with e c 2m times tn minus tn plus 1. And because of that, and we just solved that from here. Okay, because of that, I'm just going to scroll down a little bit. We end up with E equals C2m times 2 pi E. And we know from this, we're going to have this equal to C pi m WD. Okay? And now we need to figure out your WD. And we already had that above, but I can rewrite this for you. But let's wait for a second, because what we want to do now is have this equals C pi and do this first, because we want to get the WD down. So to do that, we're just going to do ln on both sides. Okay. So we do that, and we end up, we have ln xn plus 1 plus 1 equals C pi m WD. Okay, I know it's not a W. I just like saying WD. So now from above, I gave at the beginning for the frequency here. So 1 minus the c's, the coefficients, squared. And here we're going to have this equal CC2m. So because of that, we have the equals C, Tm 1 minus C squared. Okay. So because we're aware of that, we're just going to plug that into this equation over here. Okay, so this is going to be C pi 2m divided by m c 1 divided by 1 minus c squared. Okay. And now we can further this. Okay. And because of this, we have 2 pi up. So remember, let's cross this out. And we have c over here divided by 1 minus c squared. Okay. And so we have that, and that proves what we were trying to prove in the beginning. And we also find the constraints that we were looking for, which was A and B. So we have that and that, okay? Okay, guys, thank you.